The Tuscarora Lapidary Society teaches lapidary, jewelry making, and several glass arts in its education facility in Brookhaven, Pennsylvania. This video is an introduction to the TLS program in lapidary arts and sciences. Two primary branches of the lapidary arts are cabbing, the making of rounded gemstones called cabochons, or cabs for short, and faceting, the making of gemstones whose surface is covered with flat areas called facets. We also teach sphere making and Intarsia, and we teach how to identify gem materials. We will give a brief introduction to each of these subjects, including some of the equipment and processes used, beginning with the making of cabochons. Cabbing begins with slabs of rough material, such as the jaspers and piece of petrified coral shown here. Slabs can be purchased from lapidary dealers. We also cut some of our own slabs using special diamond saws called slab saws, shown next. The slab saws have clamps to hold large pieces of rough and motor drives to move the rough past the blade. Saw blades have diamond grit embedded in the edge that cuts through rough rock by grinding away the material. The blades are cooled in a bath of cutting oil that also carries away the rock dust from the cut. The Genie by Diamond Pacific, with its 6-inch diameter metal surface grinding wheels and soft back smoothing wheels, is the basic machine we use for making cabochons. Here a student is using a cab rest to grind a 15-degree angle, called the bezel angle, that will help secure the cab in place when set in a jewelry bezel. The chamfer removes the sharp bottom edge that could chip and provides room for the small bead of solder that might be at the bottom of a bezel. Here a student is shaping a cabochon on a metal surface diamond grit wheel. The cab rough is affixed with a special wax to what we call a dop stick. Our instructors provide lots of individual help. The final polish for many cabs is done on leather with soft backing and coated with a thin solution of cerium oxide and water. Here are the results from a 2-day weekend cabbing workshop for beginning students. In advanced cabbing classes, students learn to make more complex shapes. We give opal cutting courses where students learn the special techniques that help bring out the play of color in these spectacular gems. Sometimes opals are carved into non-symmetrical shapes in order to uncover and display the opal colors. We teach the faceting of all gemstones except for diamond. Diamond is the hardest gem material. Special tools and techniques are required for creating and smoothing facets on diamonds. This photo shows a Graves Mark IV faceting machine and some examples of faceted gems in one of our public displays. Currently, our classes use the Mark V XL faceting machine from the Graves Company with digital angle readout. Here, one of our members is grinding facets on a gemstone using his personal faceting machine. The faceting gem rough is affixed by a special wax or epoxy to a metal dop that is held in a quill or dop arm that can place the rough onto the rotating grinding and polishing surfaces at any desired angle. This photo shows the bottom or pavilion portion of a gem that is being cut. When the pavilion is polished, the gem will be transferred to another dop by means of what is called a transfer jig. so that the top or crown can be cut. Most faceted stones have a flat facet at the top of the crown called the table facet. In this faceted topaz, some facets were left frosted, giving a spectacular effect. This is a very popular faceting demonstration from one of our annual shows, Gemarama. Gem material can be shaped into spheres. This can be done by automatic machines. We teach how to do it by hand with inexpensive equipment such as shown here. Rough material for spheres is first cut into a cube form from which the edges are removed. This shows rough held in a special jig for making the cube shape on our large slab saw. Here is an initial stage of grinding a sphere using silicon carbide grit and plumbing reducing connections hidden in this photo for the grinding surface. It's a messy process, but it is amazing to see the rough becoming spherical because of the random positioning of the rough on the rotating cutting surface. Here the rough is spinning between a rotating plumbing connection below the rough and another held by hand. It is almost spherical. The original flat sides are now reduced to small circles. Finer and finer grits are used to smooth the sphere once it is completely round. Going from one grit to the next finer grit requires a meticulous cleaning process. For the final polishing stage, we stretch leather coated with a solution of cerium oxide over the lower grinding surface. All of these spheres were made by hand using the process just described. Intarsia is the creation of pictures in stone by assembling pieces with no visible joints, in contrast to mosaics, which usually have visible grout lines. Intarsias can be large or can be jewelry size. Here are two small intarsias. This is a national award-winning display of intarsia by member Barbara Jacobson. Individual components of intarsias with straight line edges are created on flat laps. Pictured are two flat laps that can handle modestly large pieces. Once assembled by gluing, intarsias are flattened and polished on flat laps. We also use small tabletop flat lap units. Some intarsias are too large to flatten on the powered flat laps. Here a 10-inch by 14-inch intarsia of the Liberty Bell is being ground flat using silicon carbide grit on plate glass. The good surface is down. The back side, showing part labels and excess glue, is what you see. The finished Liberty Bell intarsia is in a walnut frame. This was a society project in which 14 members contributed a total of 275 hours of work. It is important for lapidary artists to know their gem materials. We give courses in gem identification in which one learns about the different gem materials and the ways to distinguish them. Here, a binocular microscope with dark field illumination is being used to examine a specimen. One uses a variety of equipment to identify gem material, including refractometers, polariscopes, and specific gravity hydrometers. Some gems can be made synthetically and have nearly the same chemical and optical properties as the natural stone. It's important to identify which ones are natural and which have been made by humans. Also, there are many gem substitutes that may look like a genuine gem, but are actually glass or some other substitute material. This is a good example of the range of skills we teach, going from rough to gem to jewelry. This concludes our overview of the TLS Lapidary Program. Current information on classes and meetings may be found on our website, www.lapidary.org.